All right. Hello, how are we doing? So we're gonna have a section, a very good one, a very good one. We're going to talk about the Ethereum virtual machine. Yeah. So let's get on with it. All right. So yeah, this is my space. I'm Nathaniel Nanle, protocol engineer. You can meet me on Twitter, Nanle Nata 92210. This is my Twitter handle. So we're going to talk about the Ethereum virtual machine and understanding stack. Now, how the EVM works, we're going to learn this. So this is what we're going to cover in this meetup. We're going to look at what is the EVM and what is stack. What is the EVM and what is stack? The reason why we're picking up stack is you need to understand that how the EVM stores data is it stores data in stack, it stores data in memory, storage, callback, code, and log. But we minimize our study here just to understand the logic behind how data are stored in stack. And it's going to be an awesome ride. Alright, so what is the EVM? The best way to explain what the EVM is to explain it in this manner. Now imagine you have a simple vending machine that does not just give you snacks, but can follow instructions and do many things. You can tell it to count your coins, save your candy for later, or even trade toys with your friends, all without needing an adult to help. These vending machines run on special instructions. That's the smart contract. It's very important you know this. And no one can trick it or change the rules once it starts working. It always follows the rules exactly as written. Just like a real vending machine needs power to work, the EVM needs gas, Ethereum's fee, to run the instruction. The more complex the request, the more gas it needs. So the EVM is Ethereum's brain. It makes sure that smart contract works properly and that everyone plays fair. So what this is telling you is the EVM is literally the brain of the computer. Look at this. It calls it the vending machine runs on special instructions and no one can trick it or change the rules. One of the features of blockchain is that smart contracts are immutable. Have you asked yourself questions like why is it that smart contracts are immutable? The reason why they're immutable is because they follow certain lines of instructions, and these lines of instructions are captured in the EVM. They are captured in the EVM. So when a smart contract is deployed, um, data are stored either in stack, either in storage, either in memory. They are stored, all of these things. And when they are stored in stack, when they are stored in memory, when they are stored in storage, there are certain ways they are stored. So that way in which they are stored is actually the instructions with which every smart contract must adhere to. That's the reason why the smart contract deployed on the EVM are literally immutable. So we need to really then understand what the stack is. Because for we to know how data are stored in the stack, we need to understand what the stack is. So the stack in the EVM is a magic tree for instruction. Inside our magic vending machine, that's the EVM, there's a special tree where it temporarily placed items, numbers, or data while following instructions. Now imagine you want to make your hot chocolate using the vending machine. The machine does not just make it instantly, it follows steps. First, it remembers what ingredient it needs, like cocoa powder and milk. Then it processes one step at a time. Heat the milk, mix in cocoa and stir. Finally, it removes the ingredient as they are used and gives you the hot chocolate. Now, what this is telling you is what the EVM does is every time a smart contract is compiled, it does not just automatically start doing things. It reads it line by line until every opcode is implemented. That's the genesis of error. When you compile a code and you are getting error, it's just because certain lines of code are not correlating with the EVM, with the opcodes inside our EVM. So you need to adjust your code to correlate with the instructions that are in the EVM. So every error you see in your code is because they don't follow the opcodes that are in the EVM. That's the instructions inside our EVM. So this tray inside the machine works just like the stacks in the EVM. The EVM stores numbers and instructions on the stack, just like placing ingredients on the tray. So it only takes from the top, just like using the last ingredient placed first. So there's a logic we have when we store data in stack. We call it the LIFO, the last in and the first out. I will explain this further as we go on. After processing, it removes item, making space for the next instruction. Now, for example, I want to store two numbers in the EVM. So this is what my smart contract do. If a smart contract wants to add two numbers in the EVM, it first of all puts one of the number, the second number, you put 3, you put 3, and then the EVM adds them up to become 5. It updates the states. You take 3, 2, and 3, but what the EVM does is it take 2, 3, and then add it to 5, and update the states to become 5. Without further ado, I want you to see the code and how these things are working. But before we head on to the code, I want to show you how. I want to show you a material, and I will really want you to check them out. Anybody who wants to build the EVM, I will refer you to EVM from scratch. It's a very, very amazing material. So the stack is a very simple data structure. It is a list. It is a list with one restriction. You can only directly interact with the top of it. Are you getting this? You can push a new value to the top of the stack, or you can pop an already existing value from the stack. So we use the analogy of a plate. A stack of plate is a good metaphor. You can add a plate or remove a plate from the top. A stack works in the exact same way. So that's how data are stored in the stack. They are piled up like these plates. So you can only remove plates that are at the top, and you can only add. So this is actually the first plate that was added. But when you want to remove data stored in the stack, you don't remove this guy first. You remove the data at the top. That's how it works. And one other thing you need to pay attention when building the EVM from scratch and implementing the stack, what you need to understand is that the maximum data that can be stored in the EVM is 1024 data. 124 items can be stored in a stack. Now this is an implementation of the stack with Rust. I just showed you a dummy, but I'll show you these things how they work with Rust. So this is my code here. So the first thing I did here with my code is I declared a variable maximum stack size. It takes 1024 items. So the maximum number my stack can take is 1024 items. When it gets this, it returns an error. And the next thing I did is I create a struct that stores the data that will be stored on the stack. And this is an enum that just manage my error. And the next thing I did is I implement the stack just to get access to my data. That's just what I did. So the first function I want you to take note is this push and this pop function. These two functions here. So this is what I'm doing here. This function takes in value, and what we want to do with this value is we want to push this value inside of our stack. And we remember we are storing the data of the stack here, right? So the first thing my function does is it checks if the data is greater than or less than the maximum size, maximum item that are meant to be stored on the stack, meaning 1024, right? So if the data is 1024, it means it cannot, this function cannot be executed. It returns this error. But if this condition is still not valid, it means that the data stored inside of my stack is less than the maximum. This line of code will be executed. So the value is going to be pushed to my stack. It's amazing knowing that this is literally the function that is responsible for storing data on stack. It's a plus already. That every time you want to store data on the stack, these are the functions you call. These are the functions you call. So you are not just compiling data now. You're not just compiling smart contracts. You know how these things work. You know how these things work. And now if you want to see the data you stored at the top, remember our analogy here. If you want to see the item that is stored on the stack, this is the function you call, and this function return the first data that is stored on the stack. It's amazing. It's amazing. It's amazing. It's amazing. So after getting to know that these are the functions responsible, in our next video, I'm going to show you how these things literally work. I'm going to run this code. I'm going to use bytecodes. I'm going to use bytecodes, and I'm going to show you how the EVM reads the bytecode and call the functions that are inside of my stack, and how it implements this function in my next video. So watch out for my next video. I'm really looking forward to see you guys. All right, peace.